I've reached a good milestone with DDD, my DIY dev droid. It's now off the bench and mobile. In the last video, I demonstrate my rusty remote control skills, driving DDD with a DualShock 4. Before I move into the next set of experiments, I want to take stock and see how we're doing against my original ambitions. I started this project with 3 design principles: that DDD would be about exploration and not about product, that the platform and code would be refactorable, and that it would be low cost. I think the first 2 are fairly clearly achieved, though refactorability is going to be more challenged as we start adding sensors to DDD. What do you think? Let me know in the comments. I've not talked about cost so far though, and I think that is a remiss. So in this video, I'm going to talk about cost to date in building DDD. Please don't forget to like the video and subscribe. I really do appreciate it. Just a quick recap on DDD. DDD is a 3-wheeled robot for the purposes of experimentation with robotics and ROS2 using the Pico and Raspberry Pi 4. DDD is driven by 2 12-volt motors on the front 2 wheels. A dual H-bridge drives the motors and rotary encoders measure the speed. Speed management is handled by the Pico. Higher level ROS2 functions such as mapping, navigation and communication are handled by the Raspberry Pi 4. Let's take DDD through the checkout and see what that end cost number comes to. At the core of DDD, I guess, is the motors and the wheels. And they came with a kit of a chassis, a little piece of aluminium, 2 12-volt motors with rotary encoders on the back, and 2 nice big rubber wheels. They're 130 millimeters across, so it's a quite substantial bit of kit. And that cost me around about 50 quid, and that really was the kick-off point for the project. I did think about making DDD a 2-wheeled balancing robot, but then decided it's just a little bit too much hassle for my first venture into these sorts of projects. Most of my other robots have legs rather than the wheels, so I thought let's start with a 3-wheeled robot. So I need an additional wheel. So I had to actually buy 4 wheels as a set to get things that were anywhere near the same size. So that cost me about 16 quid. So for the single wheel that I'm using on DDD, let's attribute that to £4.15 to add into the project. Then we're going to have, of course, a Raspberry Pi Pico and a Raspberry Pi on board. You know that, you've seen the list already. So we're going to need a power supply. I need to be able to drop the 11.1 volts that's coming out of my battery, sometimes a little bit higher than that, down to a nice stable 5 volts to be able to run the electronics on. So that power supply unit came in at £5.99. Probably could have got a cheaper one than that, to be honest, but this is what actually I had lying around. So attributable price to the project, £5.99. Dual H-bridge. I needed some motor controllers so that we can take the PWD output coming out of my Pico and drive that into 12-volt signals going into those motors. So attributable price for that, £4.26. Again, actually this dual H-bridge I actually had it sitting around on the shelf for a bit, and so it was an easy reuse. A breadboard. Well, I need a breadboard because actually this is all development and not really quite at the point when I want to create PCBs just yet. So we put a breadboard on the top. It was an old one I had lying around, but attributable price, £3.15. Of course, a Pico, and Picos come at £3.90 each. We all know that, so that's nice and easy. A Raspberry Pi 4, this is a 2 meg version. I think I bought this for a lot less than £35 actually, because I bought a job lot of them that someone was clearing out. Let's attribute that at full price for a Raspberry Pi 4 2 gig version at £35. And a battery. I'm using 11.1 volt, 1550 milliwatt hours batteries on this. They are batteries I've had lying around. They're what I actually drive one of my hexapods on. They come about £18. They weren't quite that expensive when I bought these ones, but they are now around about £18 a unit. There's of course a logic level shifter that I needed in order to interface those rotary encoders with the Pico, and they're about £3 each. And there is some sundries, so you know, I needed some additional bolts. It's used some of the bearings I already had on the shelf and some other nuts and bolts that I had lying around. And it's used a bit of printer 3D printing filament as well, because I've printed a lot of the hardware components to actually build out the chassis and frame. So total end cost going through the till I think is £132.45. Most of which is stuff that actually I haven't really spent out directly on this build. It's been stuff that's just been reused from the shelf. So actually that's not a bad price at all, I think, for a robot that is about 40 to 50 centimetres by 30 centimetres, something like that. It's a reasonably sized piece of kit, and we built that all for 132 quid. I think I can give myself a pat on the back that our principle has been achieved. So I think DDD has largely achieved its design principles to date. I could add a fourth principle and say it's been a lot of fun to build. Hopefully it will continue to be fun as I progress further. Thank you very much for watching. Please like the video as it helps others find it. Please subscribe and hit that notification button so you don't miss the next video. Goodbye for now.